Hello 7th graders, and welcome to lesson 3.3 on subtracting rational numbers. Just like when we subtracted integers, it's going to be most helpful to picture a number line. First, let's look at a real-world example. Example 1. The temperature on an outdoor thermometer on Monday was 5.5 degrees Celsius. The temperature on Thursday was 7.25 degrees less than the temperature on Monday. What was the temperature on Thursday? Okay, so we're going to start with the temperature on Monday, and then we're going to subtract the change because it says it's that 7.25 degrees less than. So let's come up with a plan. 5.5 minus 7.25. Then we're going to draw our number line, which is already done for us. And we start at 5.5, and then we're going to move 7.25 units to the left because we're subtracting a positive number. This is the same thing as adding a negative number. We're going to move to the left. And then this is a little hard to count. I wish they marked it a little better. So notice we start at 0.5 right in the middle. First I'm going to count whole numbers. I'm moving 7.25, so first I'm going to move 7 units to the left. So 1, 2, 3, 4, 5, 6, 7, which is about right here, at exactly negative 1.5. Now we just moved left 7. We still have to move left 0.25 more. So I'm already at negative 1.5. I'm going to move negative 0.25 more to the left. Since this is at a negative and we're adding more negative, now it's just like a negative plus a negative. And if I have negative 1.5, add 0.25 more negatives, my final answer is going to be negative 1.75. So now it's like we're adding those. It gets me to that answer. All right, let's keep going. Number 1 at the bottom here, negative 6.5 minus 2. We're going to start at negative 6.5, and then we're going to move 2 units to the left. Make sure you're careful on how they count units. Notice this number line goes by 0.5. So when I move 1 unit, I'm moving 2 spaces because 2 halves is a whole. A whole is going to be 1 unit. So let's move 2 units to the left. 1, 2. All right, my answer is negative 8.5. All right, we'll do the fraction one together, and then I want you to pause the video and do number 3 on your own. Okay, so 1.5 minus 2. Now I'm starting right here. Notice the spaces are at a half, but it still counts by 1. Okay, so I'm at 1.5. I'm going to move 2 spaces to the left. 1, 2. I end at negative 1/2. All right, pause the video, try number 3 on your own, play it back to see if you got it right. All right, in the next example, we're going to work on subtracting negative rational numbers. Now, really important thing here, remember, subtracting a negative, so say I have 1 minus negative 2, that minus negative turns into a plus positive, and then we just have regular old addition. All right, so let's look at our real-world example. During the hottest week of the summer, the water level of the Muskrat River was 5/6 foot below normal. The following week, the level was 1/3 foot below normal. What is the overall change in the water level? Because we're finding the change, we are going to find the difference. So let's start where we're at now, negative 1/3, it's 1/3 foot below normal. And then we're going to subtract negative 5/6 because that was 5/6 foot below normal. So finding the difference between negative 1/3 and negative 5/6. So on our number line, notice this number line is in 6, so this is at negative 1/3. On our number line, we're going to start at negative 1/3, and then because it's minus negative 5/6, that's going to turn into a big old plus sign. We're going to add 5/6, move 5/6 to the right. Since this is already counting by 6, I just have to count 5 spaces. 1, 2, 3, 4, 5. And now this space is at positive 3/6 or positive 1/2. So what was the change in the water level? 1/2 foot. All right, pause the video, try numbers 6 and 7 on your own, and then play it back to see if you got it right. All right, so I'm going to solve number 6. We're at 0.25. Notice that's positive. Also notice this number line counts by 0.25 or 1/4. I'm going to start at positive 0.25, and then this minus negative 1.5 is like a big old plus. So I'm going to move 1.5 units to the right. And remember they're counting by 0.25, so 0.5 is going to be 2 spaces. So here's 0.5, here's 1, here's 1.5. My answer is going to be 1.75. All right, number 7, I have negative 1/2. Notice this also counts by 1/4, so negative 1/2 is going to be right here in the middle of negative 1 and 0. Minus negative 3/4, which is the same thing as plus 3/4. It counts by fourths, so we only have to move 3 spaces. My answer is positive 1/4. Joe is diving 2.5 feet below sea level. He decides to descend 7.5 more feet. How many feet below sea level is he? Okay, so he starts 2.5 feet below. We're going to represent that with a negative since he's below sea level. Then he descends 7.5 more feet. So we start at negative 2.5, and then we have 7.5 more negatives, or we subtract 7.5. Let's do this on a number line. So start at negative 2.5, and then we're going to move 7.5 units to the left because we're subtracting, where that 7.5 is represented with a negative. Okay, let's start by moving the whole numbers. 1, 2, 3, 4, 5, 6, 7. And now I still have to move a half, tiny space. We're going to end at negative 10. So Joe is 10 feet below sea level. All right, let's just fill in the blanks. Since this is a word problem, we're moving 7.5 units to the left because you're subtracting a positive number, which remember that's the same thing as adding a negative. So you move left on the number line to add a negative, you move in the same direction to subtract a positive. All right, result is negative 10, so Joe is 10 feet below sea level. All right, so let's look at number 8 and reflect a little bit. Use the number line to find each sum or difference. These are integers, whole numbers that we're dealing with. So I'm fully confident you guys can do these in your head, but we're going to use the number line to reflect a little bit on how they look on the number line and why they look that way. So in part A, we're starting at negative 3, and then we're moving 3 units to the left. 1, 2, 3. Our answer is negative 6. In part B, we're also starting at negative 3, and then we're adding a negative, so we're going to go more negative, or move to the left, and our answer is also negative 6. Now wait a minute, these were different equations. So how come they look the same on the number line? Well, remember in the last example, adding a negative is the same thing as subtracting a positive. That is an important thing to note. Okay, so let's make a conjecture. How can we change a subtraction problem into an addition problem? Let's look back at what we just did. Here's a subtraction problem. Now we made it an addition problem. So if we're subtracting a positive, to change that into an addition problem, we simply add a plus sign and we add a negative, just like how it went from 8A to 8B. A cave explorer climbed from an elevation of negative 11 meters to an elevation of negative 5 meters. What vertical distance did the explorer climb? There are 2 ways to find this vertical distance. The first way, we're going to start at negative 11, since he started at negative 11 meters. And then we're going to count up until negative 5 to see how many units we moved. Well, here, 1, 2, 3, 4, 5, 6. Oh, I reached negative 5. I can stop. The explorer climbed 6 meters. This means the vertical distance between negative 11 and negative 5 is 6 meters. So there's another way to do this. Since we know where he started and we know where he ended, we could also find the difference between the 2 elevations and then use absolute value to find the distance. So negative 11 minus negative 5, negative 11 minus a negative turns into a big old plus, which is going to be negative 6. And because this is distance, Remember when we talk about absolute value is the distance from 0, and we say distance is always positive. So absolute value of -6 is going to be +6. So the vertical distance is still 6 meters. Let's reflect on this. Does it matter which way you subtract the values when finding the distance? No, it does not. You will reach the same answer. Whichever way works better for you, use that way. All right, so then would the same methods work if both numbers were positive? What if one was positive and one was negative? Well, they would work if they're both positive. But let's see if they would work if one is positive and one is negative. So let's say the cave explorer started at -11 and they moved to +5. Now, if we're on a number line, we have -11 here. So 0 will be somewhere here, and then 5 will be somewhere here. We count until we get to 5. We're going to move 11 here and then 5 this way. So then our answer would be 16. Well, if we find the difference, let's see, -11 minus 5, absolute value. -11 minus 5 is going to be -16, which is also going to be 16. So it works. You can either find the distance or you can find the difference and then the absolute value. All right, your homework today is going to be numbers 2 through 14 even. 2 through 14 even. When I say even numbers, I mean 2, 4, 6, 8, those numbers. All right, good luck. Email me if you need help.